Hello and welcome to this video on Fission. Today we are going to talk about Kafka integration with Fission using Keda. Now, if you haven't seen my previous video which introduces Fission, talks about all the details. I highly recommend go and check it out. Today we are going to specifically talk about the Kafka integration with Keda in Fission. Now, in Fission there is an object called MQTrigger. Now, what it basically does is you have a message queue, and as the messages start arriving in message queue, you want that to invoke a function. So, the function should ideally get only the message body and shouldn't have to worry about how to connect to the message queue, how to connect, all that stuff. That's the idea though. Now, today we have two, kinds in Fission. One is the Keda kind, the other is, Fission kind. And you must be wondering, what is even a kind and should I know more? So yes, there is something you should know more. So traditionally, we had integrations developed in Fission, and they were, there's three of them till some releases. So there was Kafka, there was NATS, there was storage queue, and they were all built into Fission, triggers basically. But as we saw the Keda project and the way it sophisticatedly handles all the integrations, we decided to integrate with Keda. So as of today, the MQT kind Fission is not actively maintained anymore and is only limited to Kafka, NATS, and Azure storage queue. Whereas all the integrations which are built on Keda, they use Keda as the underlying technology. And today we have quite a few of them: NATS, Kafka, RabbitMQ, AWS SQS, Kinesis, GCP sub, and there is many more coming. Now these are the integrations that are being actively developed. That means if you're going to integrate with any system, it is highly recommended that you use Keda based integrations and not the Fission kind of integrations. Cool. So now let's look at what we are going to actually, play in this video. So we have a simple Golang function. It's called producer, and what does is it produces message and writes it to a Kafka topic. The topic is called request topic. Now, as soon as you place the message in request topic, the MQ trigger should get triggered. So what happens is when you actually create MQ trigger, we create a Keda scalar, and that Keda scalar into an HPA and deployment. The good part is when there are no messages arriving, this deployment is scaled down to 0. And only when there messages arrive in the request topic, this deployment will be scaled from 0 to 1 and probably beyond 1 as the load increases. Now, as the message arrives, the Keda connector deployment is scaled, and it puts the body of that message into a function and calls a function. In this case, the function we are going to call is kConsumer, and this function will process this message received, and if it is able to successfully process it, it will respond with 200 status code and the body. The body will be persisted back into response topic. Now, in case there is some error in the processing of that message, in that case, the function will respond with a non-200 response code, and the body of that response will be stored into error topic. Now, this is the whole end-to-end flow. I wanted to kind of double click on the Keda connector parts. Now, Keda connector, are not only applicable or useful in Fission. You can actually use them in any other, context outside of Fission as well. So, Keda connectors are built as generic connectors, which basically takes certain parameters as inputs, in the deployment, and you need to read from messages from here, and you need to deploy them here. Of course, they are backed by Keda. So they could be used as generic connectors or worker, kind of processors, which basically pick up message from X source and drop it into Y destination. Today we have about 6 odd developed, SQS. There is Kinesis, there is GCP sub, and more are coming. But you can use them in any context where you are message queues and then transforming message queues from one source to other destination. Cool. So that's a brief overview, of what we are going to talk about today. Now, Keda is on Keda.sh, and we can look at the Apache, Kafka scalar. We'll talk about that again in the context of the trigger that we built. And the demo we are going to show today is all documented on the blog here. So if you go to blog.fission.io, you'll find this entire blog, which actually shows you how to use Kafka Keda with Fission Functions. And for today's demo, we are using a DigitalOcean cluster, a 2-node cluster, and I'll go to the code and then we'll actually try running this demo. Great. So here's the code that we are going to talk about. Let's first look at the producer function. The producer function is a simple Golang function. It has a signature, which is compatible or kind of conformant to the Fission function. It accepts a request and responds like a HTTP response. And within that function, we are basically connecting to Kafka queue and dumping messages, about 10 of them, at every iteration or call. And the message is nothing but a JSON with the message ID and the timestamp. That's all, that the actual producer function does. The consumer function is very interesting in the sense you don't need to understand or connect to Kafka. You don't know, where does the response go. So all you get is the body, which has the contents of the message, and you simply use that body to do whatever processing you want. And once you are done, based on the status code, this response will be either routed to response queue or it will be routed to the error queue. So from a consumer point of view, consumer function point of view, the developer of the function has absolutely not had to deal with any boilerplate load to connect to the message queue and understand that boilerplate piece of code. Great. So those are two functions, but how do that they are connected to each other? And that's where our MQTrigger definition comes in picture. So MQTrigger is a CR, like a custom resource in Kubernetes, and it declares the response topic, the error topic, and then function reference. This is the function that will be called when there is a message in the request topic. And specific to Keda, there are some fields which are in metadata. For example, which server to connect to, what consumer group to use, and what topic to connect to, and so on and so forth. There are some more fine-tuned parameters like how many replicas you want to have max, how many tries you want to do if there is a failure on the function calling. For example, if the K consumer function is down, you want to try 2 times, 3 times, and so on and so forth. Now, all these parameters that you see in the metadata are basically what Keda needs for processing those. So if I go back again to the Keda screen, and if you look at the parameters that a Keda scalar needs, those are the same parameters that we will need in the Fission MQTrigger definition. Now, I declared this triggers and functions and environments using spec, the Fission spec. You can also do the same on CLI as well. Cool. Now it's time to go and look at the demo. So let me switch to my terminal and we will see a little bit of what's happening there. Great. Now, before I call the function, I want to show you a few things. First of all, if you go to the deployments related to the Keda connectors, so I have a K2K trigger. That K2K trigger in turn will create deployments into default namespace. And as you can see, right now the number of replicas available is 0. That means there is no pod running because there are no messages that are arriving right now. The moment we drop messages into the request topic by calling the producer function, this will scale out from 0 to 1 and potentially beyond based on how many partitions you have for Kafka and so on and so forth. Secondly, if I go look at the logs of consumer function, there is nothing right now because there is no request coming is being processed by consumer function, and there are no actual consumer pods running as well at the moment. So let's go ahead and test this whole thing by calling the producer function. We'll watch how the deployment of Keda connector scales from 0 to 1, and then on the consumer function side, we will see the logs of the actual messages. So I'm gonna invoke this function probably 2 times, so it'll drop like about 20 odd messages into the queue. As you can see, there is some change here. So the up-to-date required went from 0 to 1, and then eventually the available also went from 0 to 1. That means as soon as the messages arrive, the Keda scaled out my Keda connector from 0 to 1. Now let's go and look at the consumer function logs. Now as you can see, the messages 8, 9, 10 ID messages processed by consumer function, and there might be some more messages processed by 2 or 3 other parts of the same function. Now, as we have dropped 20 messages, they'll get processed. Once they get processed, this deployment of the connector will scale back to 0. As you can see, it has scaled back to 0. So as soon as the messages are processed, the Keda connector deployment gets scaled back to 0. Eventually, also the consumer parts also will be scaled back to 0 once there are no more messages. So that's a very brief, demo of what I was talking about, integrating Keda, Kafka, with Fission functions. I didn't, of course, cover the error scenario in the sense, if there is an error in the processing of the message by consumer function, how the message goes to error topic. But you can try that on your own. All of that is log that I just pointed earlier in this video. Great. So that was a brief demo of this whole thing working. Thank you for watching this video. And if you haven't watched earlier videos about introduction of Fission or when to use fast, when to not use fast, I highly recommend go and check out the video on YouTube on GitHub Satellite 2021, which introduces fast, why fast is important, when not to use fast. And then another video on serverless Ahmedabad, which talks about details of fission, what are the differences of fission are in terms of internals of fission. You'll find the links for all these videos in the show notes. Thank you for watching, and see you in the next video.